Hello, everyone. I'm Gunhan Gulsoy. I am a software engineer in tools and infrastructure at Google. I lead the testing and development infrastructure team in Tensorflow. And I'm usually better with these kind of setting up presentations things, but sorry for taking so long. So today I'll talk to you a little bit about our story with Bazel. So first, I'll start with talking about how we use Bazel, how we used to use Bazel, and after open sourcing, how we use Bazel. And then I'll go into some details about our builds and our going over examples, how we just overcome various problems we run into using Bazel. And finally, I'll talk about just a few open problems, like things that could happen that would make our Bazel experience much better. So first, how do we use Bazel? Before open sourcing, as you have already heard about, internally, there's Blaze. We build only for Google using Blaze, and people only needed to use TensorFlow on Linux systems internally. We have multiple languages. If you have seen our repository, we have C++, Python, SWIG wrappers in between. Nowadays, people are adding all kinds of wrappers. I think we now even have Haskell support. But that's internally, that used to be not the case. But we support multiple languages. However, internally, there's only a single tool chain and compiler we need to worry about. All code is local. Everything is in a single repository. So when we need to build, we just go to that repository, and that's it. And one of the best parts has been, since Blaze has been used for a while internally, for whatever we want to do, there are solutions that people have already implemented for us. So we just search for things, copy, paste, and it works. And distributed builds. I can go on and on about distributed builds, but it's just, you don't need to worry about not being able to use your computer while you are building, or just build however large. Like back in Search Infra, we used to build all of Search within 5 minutes, and it's just great. So when we decided to open source, I think Bazel was open sourced before TensorFlow, and we realized, oh, Bazel is also open source. So one less thing to worry about, right? Nah. There were quite a few things to worry about. So every item almost I covered has posed problems for us. So before we were building only for Google. Not anymore, we're not. Now we are building for any computer that runs, really. We still have multiple languages, but for all of these languages, people can use any compiler. Like we have users who use CentOS systems that were last installed 15 years ago, and they want to compile TensorFlow on these. And we cannot use our one big great repository now. So we just need to depend on the internet to let us download things. And I think one of the most painful things has been we just had to part from all of that accumulated knowledge about Blaze and the build system. So I think we were one of the first teams to open source using Bazel at the scale TensorFlow was using. I might be wrong, but it felt that way. But we had a lot of help from Bazel team, so I'll get to that. And one of the other difficult transitions has been, parting from our great distributed build system into this mostly local builds, where everyone wants to build on their laptop, and just comes to the painful realization that it takes ages to really build anything. So really, when doing these, at times things really looked impossible. But then we just realized, using Skylark and different approaches, how flexible Bazel has been. And I think even in some cases, Bazel team were also thinking, oh, to do that, we need to add this support. And then 1 week later, we were able to implement a solution using Skylark. So that was those were interesting cases. So with that, let me move into some details about how we use Bazel from our repository, from our code itself. I have to warn you, these are not all great solutions. Some of them are really, really ugly. Don't take us as the gold standard. However, they work. They work. People use TensorFlow. They seem to be happy, and so we would like to ditch these solutions for better ones eventually. So let me talk about how we set up our dependencies. So first, obviously, we had a single repository. Now we have a model where we download TensorFlow, and TensorFlow depends on a lot of external things. So when we are building, we have to depend on many other things. So how do we do this? Simply using the workspace file. So you can see entries like this in our workspace file. If you go to TensorFlow repository, that's the file I'm taking this example from. And once we define this dependency, you just refer to this as @eigenarchive, and then everything is available, just like it's in the same repository. No, not really, but sort of. So it works. Now we can use multiple repositories in our builds. Then the next problem we had to look into was flaky dependencies. It turns out downloading things is really flaky. Apparently, it was not just Internet Explorer that was flaky downloading things. But the problem we saw was most of our dependencies have been in GitHub. And last year, GitHub's availability was around 98%. And in the last slide, I didn't talk about it, but there was a note that said we have more than 20 external dependencies. When you add all these numbers up, you can go to a number like less than 60–70% availability for downloads. It's unacceptable, simply. So Justine from our team has designed and contributed a Bazel downloader to Bazel itself. So Bazel downloader simply lets us define multiple mirrors for everything. And it also adds exponential backups, retrying, and other measures for giving us more stability. So with that, we are able to get to more than 99% reliability for downloading our dependencies. So now we are back in business. It's great. Another problem was Bazel, since we were one of the first projects open sourcing with Bazel, and still this problem persists. Bazel is not used that widely yet. So there are many build files for projects. We download them, but what do we do with that code? So for those, we write our own build files. We maintain many build files for different projects ourselves. It's not ideal, but we are. The situation just keeps improving as more projects add just build files. And what happens here is Bazel downloads the dependency, checks the checksum, adjusts the directory names based on strip prefix there, and then finally that build file we defined there is copied into the repository root, so that once we refer to this repository, there's a build file, and Bazel knows what to do with the code. Another problem we have is system packages. One example I would like to give here is CUDA. The reason I want to mention that is not everything is as simple as we download it, then we build it from sources, or we download it and we use it. No, some of the things are like CUDA, for example, is you need to go to NVIDIA page, read all their terms of service, accept it after reading it, and download it. And when installing it, go through the same process, read the terms of service, accept it, and install it. Obviously, we cannot do these for you. So what we do instead, and this was contributed, we had some hacks in place, and a better solution was contributed to us by Bazel team and David Chen, is we ask you to install CUDA on your system first. Then in our repository, we have some not really dummy, but fake repositories, fake dependencies we create using Skylark that are just symlinks to the actual files on your system you installed yourself. So this way, you will be responsible with getting these repositories, getting these dependencies on your system, but they will be made available to our builds. And another thing is SWIG and CLIF are some dependencies that are not just simply we download, we build, or we link to our files, and that's it. Some dependencies are like SWIG. We download it, we build it. We build it. Then we use SWIG to build our SWIG files. Then those outputs are linked into our build. So these have been difficult to handle, but we were able to write our own files, write our own Skylark rules that are able to just download and build SWIG, and based on your operating system or your other constraints, just decide on what arguments to feed, build the other dependencies your SWIG wrappings might need, then actually run the SWIG command to just SWIG wrap your files and make all the things available. We just write this rule once and use it multiple times all over our repository. And however difficult the writing part has been, it now works. But not everything is a sad story like that. So protobuf is something similar. Protocol buffers are just like SWIG or CLIF. We need to download protocol buffers. We need to build the proto-C compiler. Then we need to use that to build our protocol buffer libraries. While we started with our own rules for protocol buffers, once protocol buffers maintainers decided, oh, hey, Bazel is also open source. Let's also open source our Bazel rules. Once they did that, we were able to just switch to the rules they maintained, and now it's much cleaner. So there's hope. So that's all I want to talk about today about our workspace and our dependencies. Then I'd like to go talk a little bit about our build and packaging. And so open source TensorFlow, you may or may not know, has support for different operating systems, different Python versions. You can run TensorFlow on your CPU or your GPU. We support different compilers. We support different CUDA versions. You can even compile TensorFlow for different instruction set architectures on your CPU. IBM is compiling TensorFlow for their big endian CPUs on their power systems. I can go on. But this many knobs just makes your build commands kind of ugly. We cannot just ask people to write that every time they want to test or build TensorFlow. Thankfully, there are Bazel RCs. So we just write our configure script, which asks a bunch of questions to users. And then once the Bazel RC is written out, user just needs to run Bazel build TensorFlow. So that command is bad, but it could have been worse. because of all the things TensorFlow supports. For example, we didn't include a lot of the C compiler options there. GCC and Clang share many compiler options, but Visual Studio does not. And guess what? People use Visual C to build TensorFlow. Sometimes we don't really need to ask user questions about what to use, what to do when writing our Bazel RC or compiler options For example, it can be just decided on, oh, are we on a Windows system? So let's just add these options. So we can use select statements to just decide on these in our Skylark files and let the user not worry about anything. So this is an abuse of select statements. We are sorry about that. We started with just the select part of this, but the other part just evolved. But this is just an example of how many different ways you can just add different flags to your build. Then there is the interesting problem of dynamic linking. If you just, the best case using Bazel is really, you have a statically linked C++ program. It just works. But what if we want to use dynamic linking? Since TensorFlow is becoming larger and larger, we have a lot of dependencies. And for a lot of these, it would have been just better if we could just dynamically link these, not have to build them into our binaries. Turns out it's not that easy. It's possible, but it's unintuitive. So for building the SO files or DLL files, we need to use a CC library rule, market link shared. And on macOS, we need some more work because there are some bugs around this, which I believe was fixed with 0.7 release. Marcel might know better. But this is just the rule we use to build our dynamic dependencies. This is not just the name being CC binary is not the only reason we are using our own rules to build our dynamic libraries. Bazel does not allow us to include dependencies transitively when we are using dynamically linked libraries. So our workarounds on this has been implemented recently by Ellen from our team. But let me just explain what's happening here a little. So if you have a static CC binary and you depend on multiple foo and bar libraries, and then those in turn depend on another library, Bazel can figure out all these dependencies, build everything once, link everything once, and once you build CC binary, everything is built and linked, and it's great. In case of dynamic dependencies, when you try to build your binary, which depends on foo.so, which is a dynamically linked library, then in turn, that depends on another library, bar.so. When you try to build binary, bar.so is not built. I'll skip the details for now for why this is not being built. But as a workaround to this, we just include all of our dynamic dependencies using our rule, our specific shared library rules, in all of our binaries. So that's the workaround we were able to find for this. But Bazel team, as far as I know, is working to resolve this issue. So dynamically shared shared libraries just work as well as statically linked libraries. Another thing when open sourcing TensorFlow that came up is when you have a single repository, people just depend on your code, build their own thing, and there it is. I don't need to worry about anything else. I just need to worry about my libraries working. However, in open source land, we have to build and deliver our binaries to users. So for this, we just created a bunch of scripts around what we have around our Bazel builds. So first, we need to run the Bazel build just to be able to SWIG grab everything, build our libraries, build all the objects we need. And then we need to run a bash script to adjust all the file structure. For example, in this case, we are building a Python package. So in the end is you run a Python command to actually build this package, but everything needs to be where Python expects them to be. So we move things around based on different Bazel versions used. There may be some different things. They are becoming stable, but it's possible, like if you are using an old version of Bazel, there are different things that can happen, and we handle those in our script. But this way, we were able to find a workaround for our packaging issues when we open sourced. So that's about all the detail I'd like to talk about in my talk today. I'd like to talk about a few open problems that can make the Bazel experience better, in our opinion. First, adoption. As I mentioned in my talk earlier, we maintain a lot of build files. We don't want to. We really don't want to maintain and fix build files for more than 20 projects. So it's more people use Bazel, it will be easier. And in time, this is only going to get better. But just as a warning, this is something you might also face. This is something you should be prepared. Even some Google products do not have Bazel build files open sourced. It's sad to see, but I think this is getting better. Dynamic linking, it's just not everything works with dynamic linking with Bazel right now. But it is getting better. It is in the roadmap. We are working with Bazel team to go over our use cases. They are helping us get them to work. So this is also being worked on. And finally, distributed builds. Right now, we are using the Google solution for distributed builds on Linux, that Linux builds that use CPUs. Because GPU tool chains are difficult. It is working great. I have to say it's been refreshing to just going from 40, 50-minute builds on your laptop to just ship everything. Everything is built in 5, 10 minutes and go back to work just after grabbing a bottle of water. More is on the way. But I have to say, this is a dangerous thing. Once you get dependent on distributed builds, your build becomes big, and on a local machine, on a laptop like this, it becomes unbuildable. It's dangerous, but like, God, it's good. So with that, I'd like to wrap up my talk. Here, I talked about a lot of problems, but one thing I'd like to leave you all with today is, at times, using Bazel may be difficult, but it's the examples I've shown you here, I hope, express how powerful and flexible Bazel really is. And in reality, it really helped us quickly open source TensorFlow, because however many problems there were, we didn't have to write a whole new build system from scratch when open sourcing it. So I'd like to thank you very much for listening to me ramble on about all the problems we had with Bazel and TensorFlow. And I'd be happy to answer any questions you might have.